So welcome everyone to this presentation. So it's very nice to see you, all of you in this first seminar of our series of about generative AI. So before starting my presentation, I would like to remind you that I would like to remind you that the session is recorded and that the video will be available later on YouTube. So. And also, we want this conversation series to be as inclusive as possible. So we have activated the live transcript on Zoom. So thanks to AI transcription, you can see the live caption by clicking normally on the show captions in the control bar. So welcome to my presentation. This is the first one in this series. So the whole idea of this series is that we want to initiate a conversation between AI researchers and AI practitioners and also policymakers. And we want to build a kind of nuanced and comprehensive assessment of the impact of generative AI on the society, on the economy, and also on the environment. So today I will focus my presentation on large language models, and I will talk mainly about ChatGPT, but this is not the only large language models. And sorry for computer scientists and AI experts, because it's not a very technical talk, but I will try to be as simple as possible. And I will discuss not that much about the benefits of large language models, because they are now quite well known, but more on the negative impact of these tools. So my main point will be that ChatGPT is for sure a wonderful tool, but also probably an unsustainable tool for multiple reasons. So let's start with something funny. So I found this recently. It's a cartoon. Maybe some of you have already seen this cartoon. So it has been done more than 100 years ago in 1923 by a cartoonist named Webster, and he drew this cartoon for a newspaper in New York and tried to depict a kind of fictional machines from 2023. So this year. That will generate ideas and draw them automatically as cartoon. And this is actually quite a good prediction because you see this device at the top. It's the ID Dynamo. It's a bit like the large language models, like ChatGPT-4, and the device at the bottom. This cartoon dynamo might be something like what we call an image synthesis model right now, like Stable Diffusion. So we are not that far from the reality of today. So a few words before starting, a few words about our institute. So we are a policy think tank from the UN. So we are in Macau, located in Macau. And we are addressing the key issues of the UN 2030 agenda on sustainable development goals, mostly working on the positive and negative impacts of these digital technologies, including AI, on the world, and how we can help and understand better the achievement of the SDGs. We are a multidisciplinary research team. I'm a computer scientist, but inside my team, there are people from more on the social science perspective, economics, computational social science. So because we want to address all these challenges from multiple perspectives. So you know these 17 development goals, these UN 17 development goals, they are very important for us. And if you think about digital technologies, in fact, these technologies have lots of important impact on the SDGs, both positive impact, but also negative. And I will focus on that in the next slides. So ChatGPT, ChatGPT is a chatbot. I will not maybe explain what is it, because I guess most of the people here, most of the audience know about this tool. So it means generative pre-trained transformer. It's a program that mimics the human conversation. And in November 2022, there was a new generation of this chatbot introduced by a company called OpenAI that makes the news. It's built on large language models, and I will explain later what is a large language models. And this large language models is GPT 3.5. It's and I don't want to enter into much detail, but this is based on semi-unsupervised learning and reinforcement learning. So first, let's discuss a little bit what is a chatbot, because I think this is something interesting, and maybe you have heard about this ELISA chatbot that was introduced in the 60s by Joseph Weizenbaum from MIT. So this is probably one of the first language models. It was not very large at that time, but probably the first language model, and you can interact with by prompting these kind of systems. And I remember when I was much younger during my PhD thesis, I have played a lot with these kind of systems, but it's very, very, very simple. And the idea of this researcher was to try to mimic a psychotherapist following this Rogerian school. So the Rogerian school, for the people who don't know, it's basically therapists that just repeat what you say previously. And in fact, the logic behind this, the software behind this ELISA is very simple. This is just based on predefined response of the user. But Weizenbaum was very surprised and shocked, because the people who use this software, they didn't know how the software was actually implemented, but they attribute lots of human-like feelings to the computer program. So even at that time, with this very simple technology, it shows that this kind of system has already can potentially have lots of impact on the human beings. So now, large language models, let's try to explain a little bit briefly what is it, without entering into much details. Basically, the idea of a large language model is to predict the most probable words following a series of words. So usually we call this a prompt. So a prompt might be a question that you ask the system, and the system will try to predict what words will follow this series of words. So for example, here, I have the prompt, the students open there, and what can follow this initial sentence? Basically, the students can open their books, they can open their laptops, they can open lots of different things. And if you have a big corpus, and most of the time, the large language model, they use a corpus scrapped from the internet. So if you have a large corpus, you can assign some probabilities to these different options. So you can say that 5% of the time, maybe the students open their books, and maybe only 10% of the time, this is laptops and not books. So you can use that, and can use these probabilities to generate the words, and you can generate words after words and generate a full text. So this is very interesting, because you can use that for doing text summarizations, you can use that for machine translations, and it's a little bit like these language models are close to what you can find on your phone. On your phone, for example, if you want to send a message, sometimes you have auto-completion, so the system tries to complete the sentence, and this is a very simple language models. It's not a large language models, but it's very simple. So these language models are a little bit like auto-completion, but on steroids. So it's much more complicated, but it's basically the same idea than auto-completion. So now let's move from to what is a large language model. So it's a new technology that has been introduced by Google in 2017 in the famous paper called "Attention is All You Need." And attention basically is this idea that you can provide the system with some kinds of long-term memory, and the system will use the context of your prompt to maybe generate something that is meaningful, in fact. So these systems are usually based on extensive corpus, and most of them you can, in fact, understand their performance and their sophistications by how many parameters they use. So what are parameters? But basically, this kind of system are based on neural networks, and you have to train the neural networks, and you have to provide some weight for each of the neurons inside these neural networks. And so the parameters are basically, it's a very approximative, but basically this is the number of weights that you have to train inside the neural network. And if you want to generate, if you want to have this kind of architecture, in this kind of attention-based architecture, the more neurons you have, the more parameters you have, the better the answer will be. And just to provide you with some kinds of basic numbers, so for ChatGPT, the corpus size is around 45 terabytes of text, or this is mostly text scrapped from the internet. And the number of parameters is quite huge. You see, it's 175 billions of parameters. So it's very huge systems. And the size of these systems is also very important. And I will come back later. This has a lot of consequences on the sustainability of such systems. So the main focus of this presentation is to discuss a little bit about the risk. So there are lots of risks. Maybe you have heard about some of them. There are risks on the employment. So even the very creative industries are potentially at risk with these kind of systems. There are risks in the educations for sure. Maybe also for companies, because this kind of system might provide some data information leaks. So there are lots of risk, and I will focus mainly on these three different risks. So the risk linked to the fact that this kind of systems, large language models, have a tendency to produce some misinformations and disinformations, and can be a relay for hate speech around the world. The second potential risk is about environmental risk, and so they're, in fact, because they are very big systems, you need to run these kinds of system on large computers, on grids of computers, and potentially they might have an impact on the emission of greenhouse gas. And finally, I will try to explain a little bit why the transparency issues. So because we don't have that much details about how this algorithm is implemented, and how the data come from, and how the data is curated. So I will focus in the next slides on this different risk, and maybe in future presentation of this series, other speakers will address the other one. First one, and I try to, because we are located in, our institute is located in Macau, so I try to take something that is an example that is quite local. So in fact, the first incident report, maybe you know that there is, in fact, a repository database called AI Algorithm and Automation Incidents and Controversies. And this database report, you can report, in fact, every AI accident and incident inside this system. It's a web-based database. And the first incident happens in February 2023. And it happens in China, in fact, in the city of Hangzhou. A resident used ChatGPT to generate an announcement that there will be a change in the way the government issues some number plates for driving for cars, and that the restriction will be lifted on the 1st of March 2023. And this announcement become very viral on the Chinese social platform later. So this is interesting because the ChatGPT was not supposed to understand and speak Chinese, so at the beginning. So, and there was this comment on Twitter from one OpenAI engineers that, in fact, they found that these large language models, and including ChatGPT, they can generalize to non-English prompts, in fact. And they, even if they are not being trained on English content, so it's a bit strange. So, there's no very clear answer about that. Is it a data curation problem? Because I guess if they scrapped a lot of data coming from the internet, maybe some of the text has been in other languages than English, and or maybe there is the very nice capability of this kind of system to generalize to other languages. It's not, the answer is not really clear, but this is interesting to see that large language models can be queried. This chat system can be queried not only in English but also in other languages, and even in very obscure one. Like I see some recently that some people use large language models to ask some questions in Latin, for example. So it's very strange that you can speak these very old languages like that with the help of large language models. Another issue, and this is the second incident report that you can find inside this repository database. It's about this company called OpenCage, and this is a German company. They provide some services to the geospatial community, and basically they provide a geocoding API. So what is a geocoding API? It's very simple. You give her a name, for example, Macau, and they will give you the position on the globe, so the latitude and the longitude of this city, for example, or the reverse. You can you can provide a precise position, and they will try to give you the name of this location. So it's something like that. So it's very simple. And in fact, ChatGPT falsely accused this company of doing something completely different. And in fact, at the November 2022, OpenCage, so this German company, start to see more and more people sign up on their systems and expressing their disappointment because they were looking for not this geocaching system, but for a reverse phone number lookup. And the CEO of this company provides some explanation on Twitter, and he believes that the problems come from the fact that ChatGPT trapped some information coming from the YouTube tutorials in which people described OpenCage as providing a phone lookup service and not a geocaching service. So you see that in some context, because people are using more and more this kind of large language models, it can be very problematic for companies because these systems, these large language models can maybe provide some false statement about companies or organizations. So it might be a risk for the reputation of some companies. And so I extract these two first incidents on this very interesting database. And if you are interested, you can have a look. It's very important to have this information on this database because it's completely freely available, and it's natural, and they don't they just provide this freely on the internet. So, and since the beginning of this year, so since these two first incidents, there are now more than 40 incidents related to the use of ChatGPT. So let's talk a little bit about the hallucinations, because this is the problem that we see also with this kind of large language models. So the tendency of these large language models to confabulate and hallucinate. And in fact, in that context, hallucinations means some contents that is basically nonsensical or not or unfaithful to be provide source contents. And in fact, that's been discussed first in a paper in 2017. So it's not something new, in fact. And maybe you have heard of this funny story where in the US, where I think it was in the US, where two lawyers use ChatGPT to do some research tools to find some legal precedents to support a client's case. But all the citations of cases produced by ChatGPT were completely fake, and the lawyers were complaining after that because they basically didn't know that ChatGPT was working like that. So they basically use this kind of system as a search engine and not, but this is not exactly a search engine. So this hallucination on AI system is not something new, and it has been discussed since 2017 notably in the summarization community. And I found this paper from 2017 who was the first one to say to use the word hallucination. There are lots of ongoing research to fix that because this is a very major problem in large language models nowadays. Sam Altman, the Open AI CEO, says that probably they will need 1 or 2 years to fix the problem. But people in the community, like Emily Bender, who is very famous because she was, and I will come back to the few slides about that. She was part of the group of co-authors of these papers on stochastic parrots. She says that basically this is not fixable, because the technology that the system based on this attention mechanism is basically this is built on autocompletion and not factuality. So it should be very difficult to fix this problem. One medication that we can use, in fact, is to do maybe some prompt engineering. So prompt engineering means that you maybe when you ask a system, when you do a prompt, you try to put maybe more constraint, you give more context, and the system maybe, and it usually it helps to avoid some kinds of hallucinations. Move to the next slide. So yes, I was talking about this paper, this famous paper that was published in 2018, if I remember correctly. And this was the first paper who identified lots of risk, both societal and environmental risk links to large language models. And maybe you have heard about this lady on the right, so Timnit Gebru, who has some arguments after publishing this paper. She has some arguments with the people in Google, because people in Google, they say basically that this is there is lots of false statements inside this paper, and she was later fired by Google in 2022 because she refused to remove the Google co-authors from this paper. And this paper is very important because it identifies for the first time I think the environmental risk, and I will now move to this part. So the second risk about the risk of to the environment. So if you look at the number of parameters, and so I already explained what are the parameters, but basically this is you have these neural networks, and these parameters are basically the weights for each of the neurons inside the system. So you see that the first, the initial large language models in 2019, they were around 3.4 at the multiplied by 10 at the power of 8, so 80 after the 3.4. And it was quite huge, but if you look at the current system, so in 2021, you see, for example, 1.57 at the, so for 10,000 bigger than the initial systems in 2019. So you see that this exponential growth of this system. They are much bigger, so they need more training, they need more infrastructure. So you need the bigger grid to run these models, and this is very concerning. And this might have lots of potentials regarding the emissions of greenhouse gas. And the problem is that this is very difficult to assess, because most of these tech companies they don't want to share that much this information. It's it's a secret, it's a business secret. So, and it's also very difficult to understand what is the cost of training versus the cost of running the system, because basically usually it's much more expensive to train the system that just run it. So some people try to approximate these numbers. So if you look at this first model, the BERT model done by Google in 2019, approximately 300 million parameters, and the training on some specialized GPU is it will be equivalent roughly to a flight, trans-American flight, so between the East Coast and the West Coast. So this is the cost of training in terms of emission. This is roughly equivalent to this trans-American flight. In 2022, we have some information, more precise information about the cost of this system provided by Hugging Face. So Hugging Face is also a company who are building this kind of systems, but they are building open source systems. So they are much more open to expose to disclosure this kind of information to the public. And to train their systems called Bloom, it's an open source multilingual large language model. So it's much bigger than the BERT one, and they use something like 25 tons of the training is approximately equivalent to 25 tons of carbon dioxide emissions. So 30 flights between London and New York. But this system has been trained in France, so because France use a lot of nuclear energy, maybe the impact is maybe less than this one. And finally, some people try to understand compute the equivalent greenhouse emissions for GPT-3 from OpenAI, and approximately, if you want to train the system, you will need something like 500 tons of carbon dioxide emissions. So something like 600 flights between London and New York. So you see that this kind of system is very, the cost of such system is very important. And we might expect, and there is already lots of ongoing research to reduce the size, because this is also important for the company to reduce the economic cost of such systems. Recently, OpenAI says that, in fact, probably the cost of creating ChatGPT was around 100 million US dollar, and the cost of running ChatGPT every day is something like 700,000 USD per day. So it's you see that this is also lots of cost for the company. So they really want to reduce this cost. So there are lots of ongoing research to being able to run this kind of system on maybe smaller infrastructure than nowadays. Let's move to the third part of my presentation. So I want to talk a little bit about transparency and why this is also a very important issue for large language models. And first of all, I want to remind you that, in fact, this is AI system, but humans are very important to train this kind of system. And without humans, this system cannot be trained. First of all, because the data is coming mostly from text and text produced by humans on the internet. So large language models like GPT-3, they are trained on hundreds of billions of words. And the problem is that lots of documents on internet are not, it's problematic because there are lots of toxicity and bias, and you need to purge the training data. So there is a need for curation of this data. And the solution, there's not that much solution. The solution is to use labeled examples. So you need some humans that look at the text and say, okay, this is a text with a lots of hate and violence. And so you need people in the loop to do this work. And recently, maybe you have read this story about this company called Sama. It's a company in Kenya. And in fact, so this story was because it was not very public at the beginning, and some journalists from the Time magazine, they discovered that in order to build these labels, OpenAI, in fact, used this Sama company in Kenya they sent to this company thousands of snippets of text, and they asked the company to label, to identify what are the toxic text and what are the non-toxic text. So basically, every employee has to read and to label something like between 150 and 250 documents during 9-hour shift. And the problem is that the employees describe lots of mental issues. There was not that much counselor psychologists to help to support these employees. And after a few months, the work was so dramatic that for these employees that Stama, this company, decided to cancel the work for OpenAI. So it's you see that in fact there is sometimes lots of problems because you need this kind of feedback from humans, and the companies sometimes have this tendency to outsource this kind of things, especially in some of them are outsourcing this kind of activities in the global south. So now we are almost at the end of my presentation. I want to do something fun with you, just to have your feedback. And I want to show you this very nice graph, and maybe you have already seen this graph. It's called the Dunning-Kruger effect. And it's quite usual when people are discovering a new kind of technology. So at the beginning, you see you have on the y-axis the confidence level in ChatGPT, so between 0 and 100%. And on the x-axis, you have the time, in fact. So at the beginning, there was a kind of wow effect. Yes, this is a very interesting tool. ChatGPT will be able to answer all my questions. So because the people mostly they don't understand the limits of such tools, so they were very enthusiastic about this tool. And after a while, and we have seen that with OpenAI, in fact, because there are lots of people at the beginning subscribed to this system. There was, I think, in the first 2 months, there was something like 100 million, new users for ChatGPT. So it's quite enormous for something that was not that appears recently. So there was this wow effect, and after a few months, the people say, yes, yeah, I know better what are large language models. So now I know that, in fact, this is a kinds of statistical tools, in fact, that try to predict the language. And after a few months later, they say, yes, I see that this tool is interesting, but provide a lots of incorrect answers. So it might be problematic to use these kind of tools. And maybe later we'll see the curves increase. After this decrease, there will be a kind of increase, and maybe the people, they know better about the tools. The technology will mature a little bit, so they will understand better that this is something useful in some specific situation. So they will move to the stage number 4, and finally, after maybe a few years, everyone will be familiar with this kind of things, and everyone will see the value and will understand better the limits and the risk of such activity, of such tool. So they will finally reach the number 5 stage. So you have this different stage, 1, 2, 3, 4, 5. So I want to ask you, where are you right now? Because maybe you might still be at the first stage, the stage where you are still very enthusiastic about this tool and see that it might maybe solve all your problems, or maybe you are already at the stage 2 or 3, or maybe later 4 or 5. So can you tell us a little bit? So I will ask someone from my communication team to open a poll. So is it possible, UJ, to open the poll? And I will ask you to answer 1, 2, 3, 4, or 5. So try to be honest and try to answer where you are right now, at which stage. I don't know if you can see the poll. I can open the poll if it's not. I have no feedback.
Yeah, we can see the poll.
Okay, so can you feel? Yeah, so you can feel the poll. Thank you so much, Joel. So I give you a few seconds, and I will move to the last slides, and maybe we will see the result after my last slide. So recently, last week, I attended one of the I think one of the biggest conference about AI in the world, so ISHKAI conference, who was organized in Macau. And I attended one presentation from a researcher from MIT and also someone from IBM also is working also in IBM. So Professor Pin-Yu Chen, and he was talking about these very interesting ideas that until now, computer science and AI, as this is basically engineering science. So we build artifacts, we build systems, and we try to design these systems to try to fulfill some needs of the people. And with the last advancement of AI, in fact, we see more and more AI becoming an empirical science. So it's not something, so by empirical science, I mean something that is based on observations and experiments. So we are building artifacts, but we don't know what these artifacts are doing. So we have to study this artifact after we build them. And this was the case of large language models, basically. So the Google, they build this artifact. This was interesting. This artifact has lots of interesting properties, but there are lots of consequences. There are lots of things that was not very clear from the beginning. And this becomes a new normal nowadays. So we build complex AI systems first, and then later we try to understand the consequences, and we try to understand how we can use them safely. So this is this kind of cycle, and that we have seen for example, for OpenAI. So they release, so you have fast deployment of this system. You have 100 million of users in 2 months, and there was lots of problems, and they fixed the issues on the fly. So every day they try to modify the system to fix the problems. And it has lots of consequences because the system is a little bit unstable. So it means that depending of the day that you use the system might produce some kinds of different answers. And at the end, so if we are in this new normalities, in this new reality, we need to find new scientific tools and methods. And this is basically what we are trying to do in our institute in Macau, the United Nations University Institute in Macau. We are trying to think about, we are very convinced that we need these new tools and theories to understand these kind of systems. And one of the idea that we are following is to use the post-normal science. So it's a problem-solving strategy that was introduced during the 90s by 2 researchers, Silvio Funtovic and Jerome Ravets. And this is very interesting when the facts are uncertain, when the values are in dispute and the stakes are high, and you need to take decision urgently. You can use this kind of approach where basically this is an approach where you have a more collaborative, you have a more participatory, and you are trying to address the problem from the complex system perspective and not only relying on traditional scientific methods. So I think this is maybe the way to try to solve these issues. And I will move to the last slides, and maybe UJ, can I ask you to share the result of the poll to everyone? Yeah, I'm not able to see the result. Can you see the result? Yeah.
Yeah. After I submitted my answer, I was able to see the results.
Oh, okay. Sorry, because I have no feedback. So
yeah. If
so what are the answer?
So for 1, wow, we got 4%. For 2, wait a minute, we got 25%. 3, 21%. 4, 31%. 5, ready now, 19%. So we're more or less mature users.
So we are mature users. So maybe we
Yeah.
are not I would say we are not good representative of the whole society, I guess, because people are more maybe on the 1 or 2 now. But yeah, so thank you for listening to my presentations.